Okay. Number 2. I guess we're starting with 1. I even drew you a picture. Did you see the picture, Mom?
Yes.
Okay, here's the light post. Here's the person. The light post is 3 meters tall, and the boy is 1.8 meters tall. This is his shadow, right? Because the light shines on his head, goes like this. And this is the distance away from the light pole. It says express S as a function of D. So all you gotta do is write an equation. What do you see here? It rhymes with similar high angles. Similar triangles. You got the baby bear here and the mama bear there. So 1.8 over S is equal to this over that. 3 over S plus D. Cross multiply 1.8S plus 1.8D is equal to 3S. Simplified, so move this on this side, so you get 1.8D is equal to 1.2S. And are we solving for S or D? It says write S as a function of D. So what? Solve for S, so divide both sides by 1.2, and you get S equals 3D over 2. Ma, I see a blank sheet of paper. When you came in this morning and you asked me when the test is, I thought like, oh, you are all prepared.
I was asking you when the test was, so I could know.
When's not over
Okay. Okay, we have a box with a square face. Anyway, you can't write on the board if you never even tried it.
That was, they told me to write it.
Who's they?
People.
Okay, here's the width of the base and there's the height. Okay, what we want to do is write the cost of the box as a function of W. So cost is equal to, now what is the area, how much does this box cost? What's the area of the base? It's a square, people. What's the area? W squared. But then what is the cost? How much does it cost to build the base? What does it say? $8 per square meter. So you got to multiply this by 8. Plus, what is the area of the 4 rectangles around the sides? What's the area of one rectangle here? W times the H, but you got 4 of them. 4WH. And how much does that cost? $6 per square meter. So you got to multiply it by 6. Okay, but the problem here is you have 2 variables. You can't graph this on your calculator. So you need another equation. Do they give you another equation? Yes, it says the volume of the, I forgot, this is period 3. The volume of the box is 8 cubic meters. So what equation can I write from that? What represents the volume of this box? W squared H equals 8. Therefore, H equals 8 over W squared. Take that, plug it in there. So if you simplify everything, you get 8W squared. What did I just tell you guys? Do your homework. That's it. Homework check every day from now. 0 or 5. No in between. Just one thing missing, that's a 0. Okay, so how do you simplify this? 192 over W. See, you guys just copy down what I write on the board. You're not getting the practice of simplifying, and that's why when you get to the quiz or test, all hell breaks loose. That's what happens, Ma. And the other people who are scribbling furiously. Lamb?
I did some of them. It's not this one.
Just not this one. Okay, now part B. Use a graphing calculator to find the minimum cost. So, okay, so here's the cost function. So on your calculator, you go y1 equal 8x squared plus 192 over x. And this is the key, people. You have to, You have to set the window so you can see the hump, so you can calculate the minimum. If you don't practice this, you cannot just press the graph button and expect to see something. You have to set the window on your own. You gotta. So if you can't see the hump like this, then you gotta change the window so that you can see it. Okay, and then part C. Find the value of W so that the cost is $176. So what do? Where do I plug in the 100? Here's the cost functions. Where do I plug in 176? Yeah, for C, the cost, 176. And then just solve this equation. This is last chapter. Or 2 chapters ago. Do I still need to do it? Okay, I'll just take you some of the way. First step, can I divide through by any number to make the number smaller? Because does 8 go into this and this? Yes, divide through by 8. Go, Mom, redeem yourself.
22 w squared plus 24.
Okay, and then how do I get rid of the W in the bottom? Multiply through by W. Oh, it's a cubic equation. So what do? You make one side 0. And this is a cube. And how do I factor this? Either by grouping or synthetic division. What are you guys probably going to do?
Synthetic division.
You don't even have it on your desk!
I didn't do it.
Obviously. Synthetic division. So 1, 0, negative 22, 24. So factors of 24 over factors of 1. 1 doesn't work. So the next thing we're going to try is 2. Does 2 work? No, so you try 3. Does 3 work? No, so the next thing you do is you try 4. Does 4 work? Yes! See, you guys are copying, and then what's going to happen? You guys gotta go through the process. Try 1, try 2, try 3, try 4. I can do it in my head. You guys gotta do it on paper. 1, 4, 4, 16, negative 6, negative 24, 0. So you got 0 equal W minus 4, and then you look at that, that's W squared plus 4W minus 6. You guys can take it from there, right? I don't know. So W equals 4, and then this doesn't factor, so you got to use quadratic formula. So you're going to have negative 2 plus or minus the square root of, Mason? Redeem yourself.
10.
Okay, good. Box step, that's the answer. No, why not? You can't have negative. So, plus, that's not what it says on the bottom. You know, I'm skipping some steps in between. You guys are the ones that gotta fill in those steps. That's it. From now on, if I check the homework and I just see exactly what I wrote on the board, I'm gonna take a 4 pull. Instead of minus 5, it'll be minus 20. Like over here, like if you don't show me that you're using the quadratic formula. Because I know you guys can't do it in your head like I can. Nah, you're looking guilty. If that's really your name. You guys. Okay, next. These are the easy ones. These are the appetizers. Wait till you get to number 9 or 8. Oh, those are gonna. Okay, number 3. No, we did 3 on the board, didn't we? Or was that the other class?
We did 4.
We did 4.
Oh, okay. Okay, number 3. I guarantee you now, this time guarantee, one of the word problems you're gonna have to use similar triangle. Okay, so we already saw it on number 1, but it's not gonna be that easy. Now we got it on number 3. Okay, so you're gonna see this problem in calculus next year. Okay, you have a tank in the shape of a right circular cone. I remember one year, one person drew it like this. So Some of you, that's the way I drew it. No, it's gotta be up like that so the water can come in, right? It's like, this is like on a mountain, it's like a reservoir, it collects the water. Is that you, Ken? Okay, now, here is the water in the tank. In fact, in calculus, this is how the problem's gonna be. Water is being poured into this tank at the rate of, I don't know, something like 10 gallons per minute. Can you see what happens as water is being poured in? What happens? What happens to the height of the water? It goes up fast like this, and then starts slowing down, right? How come? Yeah, because the radius is getting wider as you go, right? So if water is being poured in at the rate of, I forget what they said already, 10 gallons per minute. At the exact moment when the height is, say, 10 meters, how fast is the height of the water changing? Because, like I said, the height of the water goes fast in the beginning, and then it slows down, right? So at an exact moment in time, how fast is the height of the water changing? How fast is the radius of the water changing? How fast is the surface of the water changing? That's the kind of problems we do in calculus. If one thing changes, how does the other one change? Okay, now look at this picture. It says the diameter is 60, which means the radius is 30, and the height is 120. Okay, first of all, the volume of a cone, now here's the water. The water is in the shape of a cone. What's the volume of a cone? 1/3 pi r squared h. But again, the problem is you got two variables. You can't graph that on your calculator. So you have to get rid of one of these variables by writing another equation. And where do you think that other equation comes from? It rhymes with Himmler high angles. Come on, usually when you have a cone, it's going to be similar triangles, right? Look, can you see the similar triangles? You got the baby bear here and the mama bear there. So baby bear, r over h, short leg over long leg equals what? What's the short leg over long leg in the mama bear? 30 over 120. You want to reduce that to 1/4? No, I like to work with big numbers, Mr. Park. Cross multiply and you get h equals 4r. Take that and plug it in here. No, because it says write it as a function of h. You want to get rid of the r and only have h's, so you want to solve for r. R equals h over 4. Then you take that and plug it in there. Okay, so you get 1/3 pi times the radius squared, but the radius is h over 4. And then if you simplify everything, you will get, redeem yourself. Kang.
You get
Enough of your stalling tactics. Pi h to the
pi h to the 48.
Look, there's an h squared here and an h to the first there. Multiply them and you get h to the
30.
all over.
Sorry. And the bottom is 48. That's what I meant.
All right, there you go. And that's all you have to do in that problem. But that's the key step right there in calculus. If you can do this in calculus, the rest is easy. I'm telling you, calculus is easy. The hard part is like the pre-calculus part. Okay, next. Oh, look at the time. Are we even going to finish this? Oh, gosh. Here's
You're 8 and 9.
No, we're going to go in order. 5. And then are we even doing, everybody got 6. That's usually difficult for the students. But no, period 3 is smart. Yes. Everybody got 6, so good. Because there might be one very similar to that on Wednesdays. And yours is the class we're videotaping here. Okay, a sheet of metal is 60 centimeters wide and 10 meters long. So, in other words, it's like really long, okay, but, so you know what this is, right? What do you call something like this? It's called a trough. Or a gutter. I hope we finish. We don't get to 8 and 9 because those are the two toughest ones right there.
Can we erase something?
And are you sure you want to do number 7? That's
Yeah,
like
can
that's
we
like the
erase it?
easiest one. Oh no. Okay, so let's work in centimeters. So 60 centimeters wide and 10. How many centimeters is 10 meters? Quick. What?
1,000.
1,000. There's 100 centimeters in a meter. That's why cent.
What was the question though?
I forget. I said work. Okay, anyway, to form a rect, so we label this x and this is x. Therefore, what is this? Because it was 60 centimeters wide. What would this be? If you bend it. Look, if you have something that's 60 centimeters wide, you bend it here, x and x. What's this one over here going to be? See, we're just wasting time when we do that, you know. Okay, now, how do you find, it says write the volume as a function of x. How do you find the volume? This is a prism, right? That's what it is. How do you find the volume of a prism? The area of this trapezoid times 1,000, right? Whatever the base is, doesn't matter what shape it is. In this case, it's a trapezoid. So how do you find the area of a trapezoid? What was it again? 1/2. This came up 2 chapters in Lin Quad, I remember. 1/2 the height times B1 plus B2. Remember that? Oh gosh. 1/2 the. This is a super important formula in calculus. If you don't know the area of a trapezoid, go home, good Christ. Times 1,000. Okay, now, so what we have to do is we have to write the height as a function of x. Well, draw it in like this. Oh, if this is a 120-degree angle, what angle is this? 30. That's 60. Oh, it's a 30, 60, 90 triangle. If the hypotenuse is x, what's the short leg? Quick. This is SAT, people. 1/2 x, and if the short leg is 1/2 x, what's the long leg? √3/2x. Okay, I'll just put this all in right here. Okay, so what's the height of the trapezoid? √3/2x. What is base 1? What is base 1? What is this? Duh, 60 minus 2x. And then what's B2? Well, isn't it 60 minus 2x? 60 minus 2x plus half x plus half x, which is plus 1x, which is 60 minus x. Oh, you got it. There you go. I will let you simplify that. And the reason why you couldn't do part B is because you couldn't do part A, right? What kind of function is this? If you were to multiply it all out, the highest power would be 2, which is quadratic. So this is a quadratic function. And how do you find the, so it's going to be a parabola opening down, and how do you find this maximum point? We don't need a calculator for that. Yeah, you just do negative b over 2a, right? So there's no calculator for number 5, because you can find the maximum point, because it's a parabola. Okay, we've got to go on for 6. Good thing, what if we had to learn something today? What would happen? Oh, we're just used to it already, this part. Look, I drew you a picture! You telling me even with this picture you can't do it? Okay, here's a raft. A lifeguard is on a raft, and he wants to get to the snack bar over here because he's really hungry. Okay? And it's 100 meters down the beach as shown, so this is 100 meters, like that. Okay, the lifeguard can swim 2 miles per hour and can run at 6 meters, well not per hour, per second. Express the total swimming and running time as a function of x. So what you gotta know is rate times time equals distance, which of course means time equals distance over rate. Okay, so what did we call this? This is x, and you're 50 meters offshore over here. If this is x, what's this right here? 100 minus x. Okay, so we want the total time it takes to get from here to here. Because the fastest way to get from there to there, am I just going to swim straight over there? No, because you're swimming too slow. You're only going 2 meters per second. You can run like over twice as fast as you can swim. So probably you're going to swim somewhere over here and then run the rest of the way. So we're trying to find the fastest way to get from here to here. So we're gonna write a function and then graph it on our calculator again. Okay, so what's the distance that you swim? Oh, I see a right triangle. If you know two of the sides of a right triangle, how do you find the third? Prime to the Pythagorean theorem. You use the Pythagorean theorem. Okay, I'm not gonna. You guys gotta be able to do that. Okay, so what is the time that you spend swimming? Well, time is distance over rate. What's the distance that you swim? Harold, let me point at it. This is the distance that you swim. Then you gotta divide by your swimming rate. What was your swimming rate? 2 meters per second. Okay, what is the distance that you ran? Right there. 100 minus x. How fast can you run? 6. Oh, so it's actually 3 times faster you can run. And there you go. The time spent swimming plus the time spent running is the total time. And then you graph that on your calculator. You're going to do these exact same problems in calculus next year, except you're not going to have a calculator to calculate the minimum. You're going to use calculus. Of course, next year you're going to tell your teacher, Mr. Park never went over this. We never did word problems like this. Are we really going to do number 7? That's like the easiest one right here.
It's okay.
Okay. Number 8. A cone circumscribes a sphere. Okay, I'm just going to draw, I'm not going to draw a 3-dimensional picture because it's too hard for me. So the cone, this is a cone now. It circumscribes the sphere. I remember one year, this was a math team captain too. Even though I told them this problem is on the test, he still drew the picture like this. No choice, -8 right there. It's not even in the thing, it's the problem. Okay, here we go. Express a radius 1. No, the sphere is radius 1. Express the volume of the cone as a function of the base radius r. So here's r. So write the volume of the cone as a function of r. Now, what do you need to know to find the volume of a cone? You need to know the radius and the height. Let's just call this a h over there. So what is the volume of a cone again? 1/3 pi radius squared height. But again, we have 2 variables. You need another equation to get rid of one of those variables. And what do you think that equation is? What did I just say when you have a cone? Probably you're going to use similar triangles. Okay, here's the center of the sphere. Where can I draw in the radius to help me solve the problem? Always draw it to the point of tangency because it makes a right angle there. And we've got similar triangles. We got the baby bear on the top, except it's like not the same orientation you're used to seeing. And then you got the mama bear over here. Okay, the radius of the sphere is 1. So this is 1, this is 1. What is this then? H minus 1. Okay, so if you need to draw the similar triangles separately like that, do it. So like in the mama bear, what do you got in the mama bear? This is h and this is r. This is the square root of h squared plus r squared, right, if you use the Pythagorean theorem. In the baby bear, see how you got to flip it over? This is 1 and this is h minus 1. Can I set up a proportion from that? Yes! So, square root of h squared plus r squared over hypotenuse is equal to short leg over short leg, r over 1. There you go. That's your equation. So what do we want to do? Are we getting rid of the h or the r? We're running out of time, people. So should I solve for h or should I solve for r? Since I want to write a function in terms of r, I want only r's here. You solve for h. Okay, how do you solve for h in that equation? I see a radical. What do? You isolate it. So cross multiply. So you got square root of h squared plus r squared is equal to r times h minus 1. How do I get rid of the radical? You gotta be kidding me. Square both sides. H squared plus r squared is equal to r squared times h squared minus 2h plus 1. Distributize. So that's r squared h squared minus 2h r squared plus r squared. Oh, the r squareds cancel out. Now, do you notice that there's an h in every term? Divide through by h. And then now it's pretty easy to solve for h, right? put all the h's on one side, let's put all the h's on the right and bring this, everything without an h on the left. How do I solve for h? Quick. Factor out the h. This is algebra 1, people, and then divide. So h is equal to 2r squared all over r squared minus 1. Take this and plug it in there. And then you got to graph it on your calculator, which is probably another problem, yeah? Okay, we got 3 minutes left. You're in trouble. See how much algebra you got to do? Okay, I'm telling you right now, the probability that, I remember 1 year, all I did is I changed a 1 to a 2 and I'll have it broke loose. Is that going to happen this year? And then I got my numbers mixed up on the answers. Some of you noticed. Yeah, I think you could figure that out. So number 9, here we go. A can is shaped like a right circular cylinder. Let's see if we can get this done in 2 minutes. The volume, okay, so here's the radius and here's the height. Now you're going to build this can. Now this is like a real life engineering problem right here. What is the cost to make this can? Well, what is the material? It is to be made from material costing 80 cents per square foot. Okay? This is a can now, so there's a top and the bottom. What's the area of the bottom, quick? That's a circle. But then you got a circle on the top. So 2 pi r squared plus, what about the lateral area? Quick. 2 pi rh. Now wait, see, if you don't know your formulas, you're screwed. Multiply that by the cost per square foot, which is 80 cents. Plus, okay, now that's not all, because if you're going to put juice in this can, it has to be sealed. So you have to seal it with solder. You guys know what solder is? It's like a solder gun. It's like melted metal, like this. So that seals it. Then you got to go, that seals the top. And then that will seal it over there too. You got to seal it. Okay, so how much, what was the distance of the seal? What is this? That's one circumference. 2 pi r then. You got another one. So what is 2 pi r plus 2 pi r? 4 pi r plus h. That's how much solder you use. And how much does solder cost? 20 cents per foot. There you go. That's your cost function. But again, we got the same problem. We have 2 variables. We can't graph this on our calculator. We need to write another equation to get rid of one of these variables. And what is that? Quick, we got 1 minute. Yeah, the volume of this can is 1. So pi r squared h is 1. Solve for h, 1 over pi r squared, and plug it in here and there. And then now you can graph it on your calculator. But I'll tell you right now, if you don't practice graphing it on your calculator, okay, just for that, this problem, these 2 problems are on the test, unless they're not. There's going to be 2 word problems. And I'll try to make them similar to this. It's either going to be these 2 or the raft one. If you don't practice doing it on your own calculator, oh, all hell's going to break loose on the test. Because you guys got to practice setting the window. Set the window!
The raft one or the gutter?